All right, so we've done sine, we've done cosine, next comes tangent. So let's do the same thing. Let's look at tangent to the first power, tangent to the second power, and then we'll go from there. So first, the integral of tangent of x, that is tangent to the first power. Well, that's just the integral of sine of x over cosine of x. And that is so close to the derivative of cosine over cosine. All we need is a negative in the top. The derivative of cosine is negative sine. As always, I can put a negative on the inside, that is, multiply by -1 on the inside, as long as I divide by -1 on the outside. But now I have the derivative of cosine over cosine. So the negative sign stays out here, but this integrates to the natural log of absolute value of cosine of x plus the pesky constant. Some people write this as the natural log of secant of x because cosine of x to the -1 power would be 1 over cosine, which of course is secant. Okay, let's try tangent to the second power. It may not be immediately obvious how to integrate this, but we know that tangent squared plus 1 is secant squared, which means tangent squared is just secant squared minus 1. And each of these terms is now very easy to integrate. Secant squared is the derivative of tangent, so the integral of secant squared is just tangent. And the integral of 1 dx is just x. So tangent squared integrates as tangent of x minus x plus the constant. All right, so once again, now we're looking at powers larger than 2. And just like sine and cosine, tangent raised to an odd power, that's easy to do. Tangent raised to an even power, that's terrible. You don't want to do that. If we have to do that, we'll use a reduction formula or maybe just use technology to do the integral. So as an example, let's just integrate tangent cubed. The rule for tangent to an odd power is similar to the rule for sine and cosine. If you have tangent raised to an odd power, save a tangent and change everything else to secant. So what I'm going to do is write tangent cubed of x dx as the integral of tangent of squared of x times tangent of x dx. That is, I'm saving a tangent, so I have it for my du. Now I have to change everything that's left over to secant, but as we mentioned just a little while ago, tangent squared is just secant squared minus 1. So this is the integral of secant squared of x minus 1 times tangent of x dx. All right, so now we break this up into two integrals. The first integral is the integral of secant squared of x times tangent of x dx minus. The second integral is just the integral of 1 times tangent of x. That is just the integral of tangent of x dx. Now be careful here. Remember, the derivative of secant is secant times tangent. So even though here I have the integral of secant squared times tangent, I want to write that as the integral of secant of x multiplied by secant times tangent. That is secant raised to a power, the first power in this case, sitting next to its derivative. Once I do that, though, the rest of the integration is easy. Let me make a little room here. This is the power rule. I have secant raised to a power sitting next to its derivative, so that'll integrate as secant squared of x over 2. And we did the integral of tangent up here. That's minus the natural log of cosine of x. So minus minus gives me plus the natural log of cosine of x plus the pesky constant. I should point out that this works not just for tangent raised to an odd power, but also tangent raised to an odd power times secant raised to any power. As long as you have tangent raised to an odd power, you can always save a tangent and change everything else in the problem to secant, and then just integrate using what we did right here.